Hi, I'm Burak Tokmak and I'm here to present my Introduction to Image Processing assignment 2 slash midterm part 1 code. I will demonstrate the end results of my code and go over the functions themselves at the same time. Uh, what we're seeing here is the crop window. For cropping the image, I use the mouse movements, mouse events. To process mouse click events, I defined a callback function named mouse call. Uh, it simply what it what it does is if I press the left mouse button and drag the mouse across the screen, it draws a rectangle area, and for cropping it, I simply need to press the C button to crop it, or Q button for quitting the crop window. If we look at the function itself, this here checks to see if I pressing the left mouse button. This here checks to see if I moving the mouse while pressing the left mouse button, and here checks to see if I lifted my finger from the left mouse button. And what happens here is it checks to see if I draw the rectangle like this or like this, and assign the end and start x and y values according to the way I draw the rectangle. If I press the C button, it will crop the image according to the size of the rectangle. If I press the Q button, it will quit the cropping window, and we will be presented with the main interface of our of my image edit tool. All the other functions in my code, other than the mouse callback function, uses track bars to operate. For example, if I move the flip or mirror track bar to one value, it will flip the image, and if I drag it to value 2, it will mirror it. It does it by checking to see if its value equals to 1, and if it's equals to 1, we will use the OpenCVS flip functionality and give it the 0 value. By giving it the 0 value, what it does, it flips the image vertically, and if we set the track bar to 2, what we do is then give the OpenCVS flip functionality 1 value. If we give 1 value to this function, it will horizontally flip the image, which in turn mimics the mirroring of an image. When it's when we want to rotate the image, if we drag the track bar to 1, it rotates the image 90 degrees clockwise. If we drag it to 2, it rotates the image 180 degrees clockwise or clockwise. If we drag it to 3, it rotates the image counterclockwise 90 degrees, and in turn mimics the rotation of the image 207 degrees. And finally, if we set it to 4, we will get the original image for rotating it 360 degrees. For inverse function, if we set the trackbar to 1, it will get the bitwise NOT of the image, and by doing that we will get the inverse of the image. And finally, for normalization, if we set the trackbar to 1, it normalizes the image, and it's doing it by splitting the image to 3 separate channels for OpenCV's equalize histogram function to use, because this function needs grayscale images to work. We give it the grayscale channel values we just separated, and it returns the normalized values of them, and we keep them to merge in here, and by merging them we get the colorized and normalized version of our image. This code here is defining the track bars, and that's it. Thank you for watching, listening.